Okay, number one, I'm going to identify my a, b, and c. So a is 1, it's the coefficient of x squared. There is no x term, which means the b is 0, and then the constant, the c, is 1. Axis of symmetry, it's always an equation, x equals, don't forget the x equals. And then I have to do negative b being 0, over 2 times a. That whole thing is just going to equal 0. So x equals 0 is my axis of symmetry. That determines the x part of my vertex. So 0, comma, then plug in 0 to the equation for x. See what you get. 0 squared plus 1 is 1. Max or min. Because the a value is positive, I know this parabola is going to open up, which means the vertex is at the bottom, which means it's a minimum. So I would say min. What is that minimum value? Well, it's whatever the y part of your vertex is. I just wrote it here, the 1. That's the min or the max value. Well, that's always going to be true. For the y-intercept, that's what you get when you have a x value of 0, and then it's whatever c is, which is 0, 1. Just so happens to be the same as my vertex. Sometimes the vertex is the y-intercept. On the table, put the vertex in the middle. Then you're going to surround that. So surrounding 0, I have 1 and 2, and then on the other side, I want to make sure they're the same distance away at all times, so negative 1, negative 2. Symmetric, I can plug in 1. 1 squared is 1, plus 1 is 2. So when I plug in 1, I get 2, so when I plug in negative 1, I should also get 2. Plug in 2. 2 squared is 4, plus 1 is 5. So then I should also get 5 when I plug in negative 2. Alright, so now we graph. Alright, and there's our parabola. Number 2, a is negative 2, b is 4, c is negative 3. So we got to do negative b over 2a. So we get negative 4 over negative 4, which is positive 1. So we would say x equals 1. So our vertex has an x coordinate of 1, and then I plug 1 in. Negative 2 times 1 squared. 1 squared is 1, so we get negative 2. 4 times 1 is 4, so plus 4, and then minus 3. So we get negative 1. So 1, negative 1 is our vertex. Because the a value is negative, we know that this parabola is opening downward, so the vertex is at the top, meaning it's a max. So we have a max. The max value has to be the y-coordinate of the vertex, so negative 1. The y-intercept has to have an x value of 0. Plug it in, you get whatever c is, which is negative 3. On our table of values, put the vertex in the middle. That was 1, negative 1. Surround it. So 2, 3, 0, negative 1. I already know what the y-intercept is, 0, negative 3. So put that in for the 0, 0, comma, negative 3. So then when 2 is also going to have a negative 3. And then, I know it's a little hard to read on there, sorry. I'm plugging either negative 1 or 3. I'll plug in negative 1. Square negative 1 times negative 2 is negative 2. 4 times negative 1 is negative 4. Minus 3. Negative 2 and negative 4 makes negative 6, and negative 3 makes negative 9. I'm ready to graph now. Alright, now factor. Number 3, they have an x in common, so factor it out. X times x plus 4. I no longer have a square, so I'm done. Number 4, now there's no x term, but it is a difference of 2 squares. 3x plus 8, 3x minus 8. Number 5, okay, I have a lead coefficient of 4, so this might be a little bit trial and error. And I'm not going to just jump right to the answer because this is a solution video. I'm going to go through the process that I would go through if I were you. So for 4, multiples or factors of 4 are 1 and 4 or 2 and 2. So consider those as options. For 15, I know it's negative, so one's positive, one's negative, but I could have 1 and 15. I could have 3 and 5. I'm going to start with 2 and 2 for the first number, so 2x and 2x. And I'm going to start with 3 and 5 over here. I remember that one's got to be positive, one's got to be negative. Think about what you're going to get when you multiply 2x times 5. You get a 10x. Think about what happens when you take your 3 times your 2x. You're going to get a 6x. Ultimately, I have to end up with negative 4. If one of these is positive, one's negative, can we get negative 4? Yes, we can. If the 10 is negative and the 6 is positive, they add to negative 4. And so the 10 came from the 2x times 5, so 5 has to be negative, and then the 3 had to be positive. So that's what it factored to. I got it right on the first guess. That's not always going to be the case. But I have a 2x plus 3 and a 2x minus 5. Number 6, there's no lead coefficient, or the lead coefficient is 1. Two numbers which multiply to negative 10 add to negative 3. We're going to have a positive 2 and a negative 5. Number 7, we've got a 2 leading the way. 2 is prime, so I know it has to be a 1 and a 2, or I guess an x and a 2x. Numbers which will multiply to 21. Well, could be 1 and 21. Could be 3 and 7. I'm going to try 3 and 7 first. Think about that outside of FOIL. X times 7 is 7x. Inside 3 times 2x, that's 6x. I'm trying, that one would have to be positive, one would have to be negative because the product is negative. If one's positive, one's negative, we cannot get 11. So that's not the right combination. So let's try erasing the 3 and 7 and switch them around. Try 7 and 3. Okay, so I'm going to get different products now. 7 times, or sorry, x times 3 is 3x. 7 times 2, 14x. Remember, one's positive, one's negative. I'm trying to get negative 11. That will work if I have a positive 3 minus 14. 3 minus 14 is negative 11. So that means the 3 had to be positive, the 7 had to be negative. So x minus 7 times 2x plus 3. Number 8, no lead coefficient. Two numbers which multiply to 16, positive 16, add to negative 4. Well, that's negative 4 and negative 4. If I get x minus 4 twice, I could write it as x minus 4 squared. It's the same factor twice. Number 9, okay, I can't pull anything out of both of those, so think about numbers which multiply to 10. 1 and 10, or 2 and 5. Either of those are options. Don't know which is right yet. 6 is 1 and 6, and 2 and 3. So let's try some different combinations. Let's try 2x and 5x to lead the way. And I'll just try 2 and 3. Now I know they're both positive or negative because they multiply to a positive, but the sum is positive. So I know both signs are positive in this case. So let's try this. Outside, 2x times 3 is 6x. And then 2 times 5x is 10x. I'm trying to make 19. Can't do it. So switch the 2 and the 3 around. We'll try that. So now, 2 times 2 is 4. 3 times 5 is 15. Oh yeah, both positive. They do in fact add to 19. So there we've got it. 2x plus 3 and 5x plus 2. Number 10, 3, it's prime, so it's got to be 1 and 3. 28, could be 1 and 28, 2 and 14, or 4 and 7. So I'm going to start with x and 3x. I'll try 4 and 7. Now I do know that the 4 and 7, or whatever these two last two numbers have to multiply to a negative. So it's a positive and a negative, keep that in mind. X times 7 will give us 7x. 4 times 3x will give us 12x. If one's positive, one's negative, can we get 5? Yes, we can, because negative 7 plus 12 is 5. So the 7 had to be negative, the 4 had to be positive. X plus 4 times 3x minus 7. Okay, now number 11, we start to solve. Make sure they're set equal to 0. Factor. Multiply But a negative 28 add to negative 3, we're going to get a positive 4 and a negative 7. Set each factor equal to 0, so we get x equals negative 4 and x equals positive 7 as our solutions. Number 12, it is set equal to 0. Difference of two squares, x plus 8, x minus 8. And so we get that x is equal to negative 8 and a positive 8. Or you could also write that as x equals plus minus 8. Alright, number 13. 5, fortunately 5 is prime, so it's just 1 and 5. 6 could be 1 and 6, or 2 and 3. Let's try x, 5x, and then we'll try 2 and 3. We do know that the product of these last numbers has to be positive, so they have the same sign. The sum is negative, which means they must both be negatives. So it helps to know that. Outside x times 3x, or negative 3x rather, is negative 3x. Negative 2 times 5x is negative 10x. I'm trying to get negative 17. I can't get them from 3 and 10, so that doesn't work. So let's try switching the 3 and the 2. Okay, so x times negative 2 is negative 2x, negative 3 times 5 is negative 15x, negative 2 and negative 15 do in fact make negative 17. Alright, we have factored it. I'm going to erase this to leave myself room for my answers. So x equals, if x minus 3 equals 0, we get 3 for an answer. If 5x minus 2 equals 0, maybe I'll write that down. Remember, you have to add your 2 over, so 5x equals 2, and then you've got to divide by 5, so I get 2/5. So 3 and 2/5 are the answers. Number 14, here I noticed I can divide out a 3 or factor out a 3. Since it's an equation, I couldn't do this on 3 through 10. Since it's an equation, I can actually just divide both sides of the equation by 3 to get rid of it altogether. That's an option too. Can't do that if it's not an equation, but if it is an equation, you can do that. Divide by 3. So now I have x squared plus 4x plus 3 equals 0 divided by 3 is 0. Okay. X plus 3 and x plus 1. So we get x equals negative 3 and we get negative 1. Okay, back page. Word problems. All right, last year, $20, 70 people attended. Their total revenue would have been the amount of money times the number of people. They're saying if they want to increase the prices. For every dollar they increase the price, they expect to lose a customer. They gave us the equation for it. Here's what it means. So 70 customers, they're going to lose 1. That's like a coefficient of 1. They're saying, hey, we're going to have 70 people, but we're going to subtract 1 for every x, for every increase in price, every dollar increase. At the same time, here's the price. It's $20, but we're adding a coefficient of 1, so we're 20, and we're adding 1 x times. That's going to give us the equation. Now part A is saying, what price should the club charge to maximize the income? So really I want to find, I want to go ahead and find the vertex. And so it says you can use your graphing calculator on this. You're welcome to do that. So if we're going to do that, I'll go ahead and show us. It's y equals, I can enter the equation in the form it was in, parentheses 70 minus x times parentheses 20 plus x. We can graph. Might not be a good window. I wait for my wheel to stop spinning. It's done, so it looks like I need to change my window. Window. Okay, it went from negative 10 to 10. That apparently wasn't good. I'm going to try negative 20 to 20. I don't really know what it should be yet. Maybe I should go a little further. Let's go negative 30 to 30. I don't know, I'll go by 5s or something. For y's, I can leave the negative 10. I'm guessing the y max of 10 wasn't enough. That's how much money they made. If I think about 70 times 20, because they had 70 people at $20, that's $1,400. So at one point they made $1,400. So definitely 10 isn't high enough. So I don't even know what the max is going to be, but let me just go like 2,500 or something like that. So I'll say I'm going by hundreds. I'll just change that to -100 then. Okay. Window doesn't have to be exact. Don't get overly concerned about it. We might have to change it again anyway. I'm just going to graph it and see what happens. Okay, it looks like I need to move further to the right if I want to see the whole thing, but I'm guessing I got the vertex there. I'm going to change my window and go a little farther on the X max. Maybe I'll go to 50. Graph again, just to make sure I get the max in here. There, start turning back down. Okay, so I'm looking for the maximum point, so I'm going to use my calc. You could have also foiled all this out and done the -b over 2a, plugged it in to find your vertex. I'm going to use the maximum option here, number 4. It's going to ask about the left bound. It is to the left. I'm happy with that. Now the right bound, move to the right of the point, select it, and then your best guess. It doesn't even have to be the best guess, but it's somewhere in there. And so it tells me, and it's a little hard for you to see, but it says 24.999994. We'll call that 25. So the vertex, I'm just going to jot it down here, and then we can go back to the problem. Call it 25 and comma 2025. That's my vertex. Now let's consider the problem. What price should they charge to maximize the income? And I don't want you to answer $25, because that's not the price. 25 is what X is. That's how many times we're increasing the price by $1. This set of parentheses here, 20 plus X, that represents the price that they're that it's going to be at. 70 minus X then represents how many people will buy it at that price. So we're increasing the increasing the price by $1 25 times. So we would have 20 plus 25 is actually $45 is what they should charge to maximize profits. So then part B, what is the maximum income? So if they charge that, what's the income going to be? Well, that's the Y part. That's the 2025. So $2,025. Number 16. A photograph. It's a 6x8 photograph. They're reduced, so we're making photograph smaller. Okay. So we had 6 and we're 8. Now we're reducing it. And we're reducing the same amount we're taking away the same amount from the width and the length. We're taking away X. So the new width is going to be 6 minus X, whatever it is. And the new height or length is going to be 8 minus that same X. We want the area to be half of the original. Well, the original was a rectangle, so 6 times 8 is 48 square inches. So we want the area to be half that, so we want it to be 24. So we know the length times width is 24, so I can say that 6 minus X times 8 minus X has to equal 24, and we're going to have to solve that. So I'm going to FOIL this out, or box method, whatever your preferred method. 48 minus 6x minus 8x plus x squared is equal to 24. I'm going to switch the order of these terms on the left side, so it's x squared. Combine like terms, I have negative 14x plus 48 is equal to 24. Now I need to set it equal to 0, so I'll subtract that 24. Okay, we're in the factoring unit, so hopefully this is factorable. Let's consider two numbers which multiply to negative 28 that add to negative 14. So 6 and 4 don't, 3 and 8 do not also, 2 and 12, there we go, I think we found it. Except it has to be, they have to not only multiply to a negative 24, but add to a negative 14. So 2 and 12 won't work, 1 and 24 doesn't, 2, 14 don't, 3 and 8, no, 4 and 6, no. Looks like it's not factorable, so we're going to have to use the calculator to solve this. So let's go ahead. I'm going to reset my calculator. Might be easier than changing the window and replacing the graph. So y equals, I'm just going to go ahead and put it in this form. Y equals x squared minus 14x minus 24. Set equal to 0, so I'm trying to find the x-intercepts. That's where I'm going to find it on my graph. Let's go ahead and graph it. we may have to change our window. Okay, I know this is opening up. Yeah, it's a positive parabola. It's got a positive a value, so it looks like this. So I caught a glimpse of it here, but it looks like I'm going to need to change my window quite a bit. Looks like I need to go over farther than positive 10. Let's try 30. Looks like maybe I have to go down lower than negative 10. I don't know, negative 50. I'm just trying something. I don't know if these are going to be good. I'll try it and see how much more I need to adjust. Okay, looks like my x's are probably okay, but my y has to go down lower. So window, instead of negative 50, let's go negative, I don't know, I could go 100. So maybe I'll go by tens on my scale. Now ultimately, I just wasted some time because I don't really need to know that. I care about where my intercepts are. My x-intercepts. So it doesn't look like it's an integer, so I'm not going to go to the table. I'm going to go to calc. I want my zeros, so number 2. Now I have 2 zeros. I got one on the left and I got one on the right. There's 2 intercepts. But I don't care about the one on the left because that's a negative number. I don't want to know where x is negative. I want the positive one. So stay to the left of it, hit enter, then move to the right of the 0, and then give your guess. Now notice it says 1e negative 11, that's scientific notation, 1 times e to the negative 11th. That's basically 0, so just assume that's 0. It's not always perfect. So 15.544 should be x. Now does that even make sense? I wonder if we messed up, because we're saying that that's what we're reducing the size by. You can't reduce the size by 15. Okay, so looks like I may have made a mistake because that doesn't make sense. The other 0 is negative, which means we would actually add to the size, and so there's no way to cut the area in half. So let's so I must have made a mistake. I don't want to take up a ton of time on this video, so I'm not going to redo everything, but let's see if we can find that mistake. Maybe you already got it. So it's 6 by 8, which is 48. So we want this to be less than 6. We're reducing by x, so 6 minus x. This was 8, we're reducing it by x. We want the area to be half of what it was. Half of the original, yep, so 24. So 6 minus x and 8 minus x should multiply to make 24. 48 minus 6x minus 8x plus x squared. X squared minus 14x plus 48 is 24. Oh, here it is, right there. I had plus 48, subtract 24. Should have been a positive 24. So I apologize, I just wasted a bunch of time on that problem. Let's go edit that. You probably even noticed, and you were yelling at the computer waiting for me to fix it. Alright, that's better. Okay, well, it looks like that might even be on my table. Looks like it might cross out an integer. So I'm going to hit table instead of going through that process again. Looks like we got 0, 0 at 2. Is there any others? It was over here also. A 0 at 2 and at 12. Oh, it was even factorable, considering that. So we would have had an x minus 2, x minus 12. I didn't even have to use the calculator after all that. Sorry about that. So 2 and 12 are my answers. Only one of them makes sense, because I can't reduce it by 12 from 6 and 8. So we can throw out 12. So we had to reduce it by 2. So what is the value of x? X equals 2. So the new dimensions would be 4 by 6, which do multiply to 24. All right, number 17. Volcanic eruption blasts a boulder upward with initial velocity 2,400 feet per second. The function they give it to us models the height of the boulder, where h is the height, t is time. How long is the boulder in the air? So we're going to graph this. I'm going to go ahead and reset. I'm going to plug this one in the calculator. Negative 16x squared plus 240x. Graph it. I bet I'm going to have to change my window. I can see a little bit of something. It's going to open downward. Oops, I meant to go to window. I saw one side, not the other, but I don't know which side it was opening to. I'm going to guess I have to go farther than positive 10. Let's try 30. And then it looks like I need to go a lot lower, maybe quite a bit lower, maybe negative 200. We're going to graph this, see if we got anywhere. Oh, I went the wrong way. Oh no, okay. I just need to go higher, not lower. So I'm going to go back to that window. My y doesn't need to go to negative 200, I'm going to go negative 10, but I'm going to go up. Let's try 100. Maybe that's not even enough. Let me try 200 just to be safe. That was 200. Oh, not even enough. Not even close. Window. Let's try 2,000. Oops. Sorry about that. Windows 2,000. I'm going to make my scale by 100s. Let's try that. Okay, I went way more than I needed to, but that's okay. Now, how long is it in the air? Well, it's in the air, shoots here, and it's in the air until it hits the ground again. So I need to find that 0. Looks like it might be at an integer. So I'm going to hit my table. It's coming back down. Look at the y values. They're coming down. Up 15 seconds. So it hits the ground 15 seconds later. So that's how long it was in the air. What is the maximum height? So go back to the graph, and I want to find that maximum. So under calc, right here in blue, choose maximum, left bound, right bound, guess. So 7.5 comma 9,000 is my vertex. I'm going to jot that down over here. Then go back to the question. Vertices are good to know. So part B, what is the maximum height? Well, the highest it got was 900 feet. How long did it take for it to get there? Well, that's the time associated with it. That's the x value, 7.5 seconds. Remember, we shot it at 0 seconds. We shot it at 0 seconds. It hit the ground at 15, so it's going to be at the maximum halfway between, so it's 7.5 seconds. So at what time did the boulder reach a height of 515? This one kind of stinks. I want to find where it's 515. What I'm going to do is I want to put maybe a line at 515. I want it to be a horizontal line, so y equals 515. I'm going to go to right here and hit 515. I'm going to try this. There may be a better way, but off the top of my head, this is what I'm thinking of as an option. That's when it gets to, that's a height of 515 right there. So I want to know when it gets to a height of 515. Well, it happens twice. So if I go to calc, I can find the intersections. Calc and the intersect, which is the 5th option. I'm going to find this first one. So first curve is about there, second curve it's about there, guess it's about there. So 2.59 roughly. That's the time, and that's about times. So 2.59 seconds. And then let's find the other one. I don't even care about the height. We know the height is 515. Go to calc, second calc, intersect, first curve. Let's move closer to that other one, the other point. It's about there, there, there. So 12.41 is about it. So let's see, another option, if I wanted a height of 515, I could have plugged 515 in for here. That's probably maybe what should have done if I wasn't going to use the calculator. I would have said 515 is the height, negative 16t squared plus 240t, no, 240, not 204. And so then I'd set this equal to 0. Minus 515. Plug that equation in. So I really am adjusting my graph or moving it down accordingly. Then I don't need that second one. Graph that, and then you'd find your y-intercepts. So where are my y-intercepts? They're not integers, so you'd go to that, your calc and your 0 option 2, and you go through them one at a time. And we should get the same answers. It's about 2.59. And, you know, we would do the exact same thing to find the other one, but we should get about 12.41. So a couple ways we could do that problem. Thanks for watching.